I think the rule is we want to minimize the number of conditions. So we only put necessary conditions, and also we can also have a fail, like fail phase, but it's not necessary because for ready, when it is false, that is basically equal to the volume snapshot is failed. So we want to reduce the number of conditions.
But only if pending.
So
when pending is false, that means you don't know whether it is cut or not. The snapshot is already cut or not. But when it becomes true, so you know that point, the snapshot is created at that point. Yeah.
Ready equal to false doesn't necessarily mean fail.
Ready equal to false. Yes. Here we will treat ready equal to false because this is called condition. So it's not like when the snapshot, the object is created, there's no condition. So whenever you have a new condition, you add it. So you are not saying like you already have a pre-existing ready condition and it must be either true or false. So at the beginning, it's no condition.
So these conditions don't all exist at the same time.
Right.
You're saying that they get created incrementally when a signal
Yes.
comes from the provider?
Yes.
So they get added. It's an additive list. I was speaking to Tim because I was planning to use conditions for CSI as well. His feedback was that we're moving away from conditions now. And instead, the problem with conditions is we end up encoding a state machine into our API. And that's something that we don't want to do in Kubernetes. Instead, what he suggested was try to simplify it into the spec itself to say the object itself should just encompass what the desired state is. And I can't put it as simply as he does. We'll pull him into the API review, but we'll go over this again before it goes to beta. I don't think it'll be conditions as the final API.
But yeah, we can go over that again. But so before we even have like phases, but I think we don't want to use phases, and instead we use conditions. That's the current all the API objects to represent the state. Yeah.
So my question is, as a user, I would like to know three things. First, I shut down my application. It's all shut down, and then I execute a snapshot.
Right.
With these states, how do I know that I can start my application again?
So when the pending becomes true.
But pending, okay, so pending is true, I can start my application again.
Yes.
Then I can create another volume from the application when ready is true.
Right.
Okay, all right.
Yeah, that's the key time in these
So pending
two states.
false, ready false means it's taking the snapshot.
So during pending, you don't have ready conditions. So remember, we add condition.
Okay, so pending false is
Right.
I'm waiting for the snapshot to be taken.
Yes,
Okay.
yes.
Well, I think it sounds like there's going to be more discussion on this, which is good, because I think if it's confusing for everybody in here like this.
Yes, yes. Next time maybe I draw a timeline so we know exactly each condition represent which time point. Yeah. Instant, yeah. So it's we have to kind of maybe there is a selected delay, right, when the pending change to true when the snapshot is cut, and this takes a little bit of time to add this pending condition. Yeah.
Hey, this is Rohit here. So pending, as a consumer, this pending is not intuitive enough for me to resume the application. Can we have a better name for that?
So you want to have a better name. So either maybe creating or created. So for example, in GCE PD Cloud, they have like 5 phases: creating, I think, creating, uploading. I forgot the rest. And
no, so the reason why I'm saying is, as a consumer, let's say I'm looking at a volume snapshot object. it is saying pending state. So how can I start my application? I need to
Yes.
understand its real meaning, right? So
Right.
it
We
should be
need to either have a good documentation, like explain what each condition and the true or false represent, or we can have a different name. But right now, like it's just what we suggest, and anyone can give their opinions, and we can vote or pick the one that's like agreed by everyone.
How about triggered and available kind of a thing?
So as a user, how would I tell ready false from that the snapshot hasn't been started yet and ready false from there was an error?
Let's keep moving. I think this area needs to be refined. We're going to do an API review and see if we can improve it. And we'll revisit it in the future.
Before
We
we
don't have to
keep
design it
moving,
here.
if anybody on this room wants to start a thread on storage SIG, we can go back and forth. That'd be great.
That'd be
Anyone want to
perfect.
volunteer to do that? We just had a lot of people who seemed really into it 2 seconds ago. Who wants to send an email and give their opinion there?
I volunteered John. I've already signed up for 3 items.
Okay. John, you've been voluntold, evidently. Is that okay?
Thank you.
All right, thank you.
So sorry, one thing that keeps coming up in the SIG meetings is that we need to check with the SIG API and the SIG apps folks about this snapshot design. What's the status on that? Because I think we all know, for the most part, where we are now and what
Yes.
we're doing with the external provision and what are the plans for, because there's always seem to be something that keeps this from going forward, from going in 3. What are some of the
resources for it, right? So it's, you don't really need API sign off.
So I think one of the things that I'm still kind of waiting for in this presentation, and one of the reasons that we did pull in the apps folks, or the apps folks actually reached out to us, was we wanted to make sure that we understood the use case and the use overall from their side too. A lot of the apps SIG deals with applications that sit on storage, and some of them have different needs for how snapshots are going to work. We need to make sure that it coordinates well with what's going on over there. And so that's the part of this presentation that I know I'm all, I hate to say it, a Twitter about. So I'm hoping, is that going to be included too in what you're presenting today?
Yes.
Or okay, great. So I think we should talk
We're
about
in
that.
phase 2 of this currently, right? Like we consider this like phase 2 of the snapshot design.
I don't know what phase 2 means.
Like we should have another design doc for it and comment there. That's what I'm saying. It seems a lot of changes we want to make. Maybe we should have like a Google Doc and do like weekly calls. Like
Yes, I already have the API spec design doc, and so I can post it again. So I already shared, I think, with the SIG storage, but I can put it again and then highlight some items that we discussed here, and then everyone can give a more detailed comment.
because we were having like weekly calls to
Yes.
discuss this, right? And then we
Yeah.
kind of cut our phase 1 feature. Now we're at like phase 2 of this, and maybe we
Yeah.
need to restart the calls.
If I'm not mistaken, there's already 2 design docs.
Yeah.
and this is different from both.
Snapshots are fun because, I mean, first off, I love snapshots. I admit it. I came from NetApp and I use them all the time for everything in my life. And they're exciting technology. They're things that we definitely want to put inside of the, Kubernetes API. Understanding how to do it is the question. Implementing it's really easy and straightforward. I mean, I think we just wanted to put, a deadline and all of us could just go and code it up in a very short amount of time. It's just making sure that, we have something that's consistent everywhere. So that's basically it. It sounds like for this piece, do we even have a list of all of the design docs? It seems like there's been a bunch of them floating around in one place. I'm looking at Brad, I guess, who's been on this for the longest.
I think often in that spreadsheet we do at beginning and then revisit at the end of a release, there are links to these kind of documents put in there. Occasionally in that spreadsheet, I've noticed the link is missing, but there is a column for it to go there. And I don't know, I can live with that as kind of a workflow process for this group.
So we had
Yes,
2, right? That merged into 1, and then we kind of dropped the release in the external repo. for 1.8. And
Right.
now I think we're in phase 2 of snapshots. I don't know if the design has been reflected to update all of this stuff.
Yes, most of the part is updated.
Okay.
Yes, yes. Yes, like we mentioned, there's design doc and also feature doc and also the repo in external storage.
Right.
So I'll put all the links and highlights what we discussed
So
here.
that's to say, like, that's a good place to have these kind of discussions, right?
Right.
Instead of,
Right.
I just pasted a link to the design doc as of, it's dated July 17. I think that's the latest one in the meeting notes. So it's there if anybody wants to look it up now.
Yeah, I have two. The old one is quite long and I have too many comments. So then I start a second one focusing on the API spec. Yes. So I think for now, we may want to comment on the API spec design doc. Yes. And so the second object is volume snapshot data. So after the snapshot is created successfully, we create this data object. And we'll put the snapshot ID information into the data source. And since it binds to the volume snapshot, so it has the reference to the volume snapshot object. And for persistent volume reference is basically used for restore volume provisioning. And here, I'm not sure it's big enough or not. So basically, I just put, based on current spec, what it looks like for each volume snapshot and the volume snapshot data API. And so we already discussed volume snapshot has spec and status. And the status contains a list of conditions. And right now, whenever a new condition for snapshot, whenever translate to a new condition, we add a new condition into the list. And for data, it has the spec. And for snapshot controller, so it's the basic functions is quite similar to, let's say, PV controller. So it watch the volume snapshot API objects like the add, delete, update event. And then for the add, update events, it will trigger snapshotting through different volume plugins. And remember, this is asynchronous call. So it will return immediately, but you don't know what's the condition exactly. You might not know. So then after that, we need to periodically query the snapshot status and then update the volume snapshot conditions. And the controller also create the volume snapshot data with the ID information and bind snapshot with the data objects and periodically update the volume snapshot status. And for delete, it's simple. It's just first delete snapshot through volume plugin, and then it needs to delete the data object too. So because for all of these, it's different operations need to go through to create the volume snapshot. So failure might happen at any time point. And we need to make sure during design the controller, so need to make sure whenever like controller may start or restart at any point, we need to make sure there's only single snapshot is created. We don't want to have multiple snapshots created when controller restart. And also we need to make sure the volume snapshot data objects created and bind to volume snapshot correctly.
So,
yes.
Hey, question. So triggering a snapshot is done by this thing called the cloud provider.
Yes.
And it doesn't go through provisioners or volume plugins or anything. And I looked at the code that is checked in the external storage repository. There is no what is it? The design doesn't, the code does not accommodate multiple storage systems. So if I have two storage systems, like in the cloud, it might be easy. EBS snapshots are EBS snapshots. There's no other type of volume. But but on an on-prem Kubernetes cluster where you might have a NetApp and an EMC, the cloud provider is one thing, right?
Okay.
And you ask it to create a snapshot.
Yes.
All it gets is the volume snapshot object. So it can't, the cloud provider code can't decide, should I take this snapshot or that snapshot? So it kind of restricts only one storage type or one storage type of device in a cluster.
Okay.
And I was wondering if it was just a prototype or the design has some problem or something.
Yes. So for current design, so we are like prototype with the GC and AWS and OpenStack. And for the scenario like you just mentioned, we need to visit the API spec to see, like, because it needs additional information to be to trigger the snapshot. If yes.
And another thing is, it's nice that we use the PV model for volume snapshot and volume snapshot data. But at the same time, we don't use the watcher kind of thing. So when a user creates a volume snapshot object, the controller just calls into the cloud provider instead of the snapshotting code listening to objects.
No, we have the controller, snapshot controller. It's like PV controller, right? Watch the volume snapshot API object.
Yeah. Sync both ways, which you know, right? If you create an AWS snapshot in EBS on your own, it's not going to show up as a new object. You create the snapshotting object, and it takes a snapshot in EBS.
Okay, my understanding was because in the design doc, in the latest design doc, the process is a human first quiesces or freezes their app, then it creates a volume. They create a volume snapshot object in Kubernetes,
right.
And there is a call to the cloud provider made to create the snapshot,
right.
And it's not the other way around, that like the model like a provisioner which says I'm going to listen for objects and then create a snapshot.
Maybe just keep that part. Maybe it was just not detailed enough. Just skip that meaning.
Okay.
It listens for objects. It watches for.
Okay. Then I'm mistaken. I'm sorry. Then I'm mistaken.
Okay. So yeah, we can like discuss offline if you have more questions related to that.
So with respect to goals and things like that, do we have particular performance objectives for the overhead that Kubernetes is adding to the taking of a snapshot, right? So particularly, you know, for the storage vendors out there that can take essentially instantaneous snapshots, and we're basically doing something that is disruptive to the application, right? We're stopping its I/O, so that we can take the snapshot. Do we have somewhere, have we called out what sort of performance we are trying to hit with this? And, you know, do we have?
It'd be impossible to find. I mean, some of them may take an hour, some may take a minute.
Well, except that we could define within Kubernetes what the API and the controller and the API overhead, and such that, you know, if the vendor can do it instantaneously, you know, maybe we have a limit that we will impose no more than 1 second on this. And so, you know, you could expect then to have a 1 second latency on your snapshot, right? And so you could have that as
recently
your
we
SLA.
in Kubernetes we add some like metrics to measuring the volume operation. So like taking snapshot is also considered one of the volume operation. So we can monitoring and have those metrics, and will give us some idea about the overhead of using create snapshot within Kubernetes compared to the like native snapshot. So yes. So no, the volume metrics, operation metrics is a separate separate like feature, but it's very easy just to also have this similar like metrics show up in the volume operation. Yeah.
We can put that in there. I mean,
Yes.
The current code is just all it is just a call to the back end.
Yes.
That's it. There's nothing in between.
I think his question is much more serious, as in when I run kubectl, is there any guarantee that it will come back in like 3 seconds? It depends on the load on the API server.
Yeah.
I guess your question was like, as a user, yeah, yeah.
Quality of service that I need to maintain for my application. Can I run it in Kubernetes? Right? Is the question that comes down to at the end of the day.
And that comes down to that comes down to like how long the application's frozen for. Right? That's the key thing. Is
that's right.
Freeze my app. We don't want limitations in the API or any type of latency introduced at the control plane layer of Kubernetes. That's going to extend the time that my app's frozen. Right.
So.
Isn't that a broader question, a broader problem? I mean, that's a kubectl. I mean, an overall Kubernetes.
So you can, so other snapshotting solutions have fixed this by quiescing as late as possible. And here currently our flow, and this is because it's a prototype. No, the design doc says the human should go and freeze his app, then run the kubectl command, and then unfreeze. But kubectl is dependent on so many things that you cannot get a guarantee from kubectl. And so if you compare it with other snapshotting solutions, not in container world, but in traditional data centers, what they do is they do everything up front, and then they say, quiesce the app right before you're making the snapshot call. So to give guarantees, you might have to do something where user doesn't quiesce the app. He creates a snapshot object. And after kubectl has created the object and when the call into the cloud provider has been made, that's when some magic happens and the app is quiesced, snapshot is taken, and the app is unquiesced.
You're missing the point I'm trying to make, though, is right now today, Kubernetes is not doing the quiescing of the application.
Yes.
Yes. So actually, in the future, kind of a plan. So we are considering have we called the external controller that we can design controller to automate the whole process. So by pause the application, because we can put some application specific commands into the controller and pause the application and immediately trigger the snapshot to minimize the overhead, like during this whole process.
So there are workflows today in Kubernetes that depend on kubectl when you involve things like upgrades or maybe some other items. And we are adding another one here for snapshots, and the way applications, it sounds like, are using snapshots, if they're going to be freezing their application or pausing the application and then waiting for some snapshot operation and then using kubectl again to unpause it or schedule it again, it falls into that pattern, but it also falls into all of those risks that people have today when they are either auto scaling or doing an upgrade. And the general pattern though of Kubernetes is that the code keeps working and the application is in the data path is going to be fine even if all of Kubernetes pieces fall over. This is different. And I think that's what you're trying to address, which is saying that by having this workflow this way, we're creating a dependency on a control plane that normally doesn't have that dependency. That's the only point you're trying to make?
Yes,
or the big point you're trying to make?
You're putting the control plane basically in the data path, in that you're doing something that the latency of the control plane is directly affecting the availability of the app, because my app has to effectively stop while the control plane does its thing.
Yes.
Right. Whereas like scheduling a pod, it can take a while to schedule the pod, and that's okay. But this is potentially inducing an application failure.
Right. So here, remember, this is the basic function.
The one piece about that is it is if you are using your application in this manner that makes it dependent on coming back up quickly from that thaw. Not all snapshots can do that or need to do that, but I agree in this case that's absolutely right.
So, Michael, most enterprise traditional apps like Oracle and
Dude, I get it. You don't have to explain it. I mean,
no, I was saying I might not even be able to relax my SLA.
I still get it. I mean,
Yeah, and the point is, I'm speaking loud because I don't have a mic, and I don't want a mic. Microphone. So I can. So I get your point as well, and I agree. But I guess what I'm saying is, if it were up to me, what I would do is I would not introduce any of the quiescing or anything else into the control plane, at least not right now. I would avoid that. And I would say, hey, it's up to the user to be smart enough to know, hey, okay, I need to stop my application or stop whatever I'm doing, take the snapshot, and then turn it back on.
And this is why we've been talking to SIG apps, because it looks like there's a lot of apps that don't need to do any of this quiescing at all anymore, more of the like container native or cloud native or whatever is hipper on GitHub than stuff that existed before GitHub. Yeah, Steve's laughing at me. He has the right scientific words, and I talk like a plumber. But you know, there are legacy applications that don't fit that way, like maybe cloud, MySQL or Postgres or items like that. And a lot of them get away with this by doing master-slave or high availability relationships, so that you would make the snapshot come in and come out. I still see the need to do snapshots in the Kubernetes API. And I also agree that trying to minimize it as much as possible seems important to me. I'd love to have a way to not need to do it and have this completely done by the DBAs. I can see why you'd want to have your application maintainers say, fire off a snapshot, and that's kind of it. It's almost like a fire and forget. Is that sort of the model that we're discussing at this point? That's a question. Because if it's not a fire and forget, it's like a fire and we'll wait to see if it works or not. Is that sort of the workflow that we're discussing then? Or because we're not talking really about wanting to either pause or interrupt the app or anything else? Like what are we looking for? What problem are we trying to solve?
I think the current model achieves crash consistency, and we would just discuss how to get to app consistency with the constraints that we have from the original question.
So I guess where I'm trying to get with this is that, you know, the application may be able to buffer its I/O, but that's not unlimited, right? So we need to bound the overhead that we're gonna cause with this. So it can, sure, have it fire and forget and script it or something, right? Such that I can, as an admin, say, you know, take the snapshot and, well, you know, we'll get a snapshot sometime in the next 5 minutes. And, you know, it will, as a part of that, you know, I've got scripting in there that can, you know, quiesce my app and unquiesce it. But that time, when it is quiesced, that time needs to be bounded.
So for the design of the snapshot controller, we consider we only want to support the like create, delete, without like including the application interaction. But we can have higher level controller that be able to go through this process. And this is also current in discussion with some workload team. They have like external controller, and it's very likely or possible we can have this. So to pause application in the controller and then trigger snapshot instead of doing like manually user like first pause the application and then use kubectl. So that's still have, but we need higher level control instead of put everything inside of the basic snapshot controller.
And I have the experience of having worked on several enterprise backup solutions, and I can tell you there's basically two ways people want them to run. One is this external controller that keeps the schedule or whatever. It initiates a backup and tells the application to quiesce. The other scenario that is definitely, if perhaps even more popular, is the application itself, like Oracle, has a CLI that you call to back up, and it wants to signal, it wants to say, snap me now. I think that for a full solution, you gotta provide both the solutions, and they are two different solutions.
So one risky thing we can't escape until block storage comes in is that no matter how modern the app is, the file system is still in the picture. And we can corrupt the file system. It's there, it needs quiescing.
Yeah, and these app initiated ones will typically make the call to flush the file system too, so you don't need to worry about it. But the external one, that's part of the reason people don't like the external solution, is there's actually not a great way to guarantee that everything gets captured.
10 minutes left in Jing's presentation. Let's see if we
Yeah. Okay. So this is for the controller design. I'll quickly go through this.
Jing, if you have 10 minutes, do you want to jump to the use cases and the workflow examples? Or
yeah, so this is kind of part of the use cases. And this is the first one is the very simple workflow. You have snapshot YAM file. Basically, you give in the spec the claim name, and then use kubectl to create snapshot, and the controller will trigger snapshotting. And after it finish, you will see volume snapshot and volume snapshot data objects. And this is just one example of volume snapshot data objects. And you can see the condition changing to pending at certain point, and then later change to ready at another later time point. And so in order to restore, sorry, this kind of messed up, but in order to restore or create new volume from snapshot, you have a PVC YAM file, and then you put snapshot source, which is the volume snapshot name. And it will go through the same provisioning process, create the volume from snapshot, and then PVC and PV binds. And this is mainly for the single volume backup and recovery use cases. And we also consider it would be very useful to replicate data, especially for our stateful sets application. So for this kind of stateful set application, the data will be distributed across different replicas. And in the stateful set YAM file, you can just add one line saying the snapshot source, which is the snapshot you already taken. And when you create this stateful set, it will automatically create all the volumes from that snapshot and bind PVC PV. And for each part, we'll use that volume. So you pre-populate all the data from the snapshot instead of creating all empty volumes. And this is one useful case for a stateful set application. And another user scenario is considering to scale up stateful set. So when application running, if you want to scale up your stateful set, so the new pod will join in. But without snapshot, the new volume created for the new pod will be empty. But in many use cases, the pod, like the application, assume the data already there. So during the application running, so with snapshot, you can periodically snapshotting the volume and change the snapshot source name into the stateful set YAM file. And when new pod is created, and the new volume will be created from the snapshot. That means the new volume will contain the data required for the pod to run correctly.
Sorry, real quick.
Yes.
So for scaling the stateful set, like what an example application is asking for this type of functionality?
So for some MySQL application, and they assume, so when the pod joins in, the new pod joins in, they need to access the data. So especially for master-slave application, and when a new pod joins as a slave, they need to assume the data already there. And currently they use some external, I think it's called clone, like extra clone. So basically directly copy data from master to the slave. Before the pod they have some innate container to do this step, and then the pod can run. But this will kind of hurt the master's performance because it is still running, and will directly copy data from master to slave, and probably more overhead. But with snapshot, it won't affect the master's performance. And it's very easy to just pop the data into the new volume. And a more complicated case is the multi-volume stateful set. So instead of data replicate across different volumes, data may be sharded across different disks. And that means all the volumes need to be snapshot at almost the same time. And so, as I said, currently we are working with workload team, and they have a Lambda controller that is in prototype that might be useful to coordinate the application-specific signaling. So, as we said, this high-level controller can automate like pause application across different nodes, and then flush the data before taking a snapshot, and then resume.
Jing, just a quick question. Where is the requirement to snapshot stateful sets coming from? Like, who's asking for this?
I can answer that. It's part of it is me and Tim and these guys. When we first started talking about snapshots, it felt very much like what was going on was, hey, there's a cool feature that exists in storage systems. Let's expose it in the Kubernetes API. And what we wanted to do was take a step back instead of doing that and try to be a little bit more thoughtful and consider how it fits into the Kubernetes ecosystem. Instead of just throwing the feature in there and letting users figure it out, we wanted to say, are there opportunities here to really improve the user experience in a container native way, something that'll be unique to Kubernetes? Let's look at this as an end-to-end workflow. So that's when the apps team got involved, and we wanted to make sure that it would work with stateful sets and maybe consider deployments or upgrades. If you have an upgrade going from one version of an application to another and it fails, could we use snapshots to do automatic rollbacks and things like that? And if we think through those use cases and design snapshots with those use cases in mind, it would be much more useful than having this feature just expose a knob and then hope that it'll fit in the way that we want it to. So I think to Brad's point, a lot of it feels like this is already done. Why aren't we pushing this into the main repo and getting this out the door? It's because Jing has been working with these teams to try and address a lot of these scenarios end to end.
So this is the move from like incubation into like entry. Do we have a breakdown of what use cases we want before we move it entry?
I wanted to finish the. You're interrupting. Sorry, he's my friend. I'm just messing with him. So so I have a counterpoint, which is stateful sets that use claims, right? Because they don't all use claims, right? Yes. Stateful sets that use claims like Mongo, Gluster, other, HDFS or whatever, they have their own way of snapshotting that are done at the data management platform. And they don't need us to snapshot their stuff. And so all I'm asking for is I'm just sort of raising the potential that we might do all of this work, but it not get used.
Yeah.
I think that's fair. What we want to highlight, though, is we want to figure out what the actual use cases are going to be and figure out how they're going to be used, whether it's stateful sets or it's some other higher level Kubernetes primitives, deployments, whatever it is. Let's think through those and make sure that snapshots are going to work.
To Steve's point, I'm even more curious who the customers are or who the users are going to be. Because, I mean, what storage systems right now don't do this on their own? Or don't, I'm guessing, I remember the old days, like Oracle would just have all this stuff built inside of its own infrastructure, manage everything itself. And if we were to offer this, it would be just something that wouldn't be employed. I'm trying to find, I guess this is why maybe use case isn't the right word. And I feel like, some of us have been using it like a stick a little bit. And poor Jing has just been trying to find out exactly what we mean when we don't know what we're asking. Not Steve. Steve knows, but I'm talking about myself. Steve, I hope, is a friend. But what are the systems that would be using this if we had it? Because we do know that it is a very powerful knob, but trying to figure out how to integrate it, that would be helpful. And that's the thing where we went to the SIG apps folks, and I don't know what their answer is, and I don't know if you talk to them and what they say the answer is too.
Yes, when I talk to them, like they have a few, like just I mentioned, for the stateful set, and they for MySQL.
But yeah, stateful set isn't it,
yeah.
right? Like MySQL is a good one,
yeah.
but stateful set.
And so in their example, right, they have to use the external like clone data to put the innate container to copy the data from the master to slave, and it's not, I think, available directly for those stateful set application to take care of all this. And with snapshots, it's very easy for them to perform this step to like copy data from different parts. Yes.
I'll just second that. Both MySQL and Mongo, we've seen this use case, and even the public Helm charts for Mongo do this in the init container. We've talked to customers who are actually running, terabyte Mongo instances in GKE, who want to use snapshots for the init, for scale, for whatever use case, instead of copying, which they're doing today. So I think MySQL and Mongo are really two really good examples.
Yes, this is from the MySQL application, yeah.
Does it have to be from a snapshot as the source though? Like what if you have a separate workflow where you're creating a volume that you use as a read-only mini volume and you want to just provision your PVCs from that? It doesn't have to be a snapshot, it could be some other PV.
So that's how you kind of put the data to a second volume, either copy right now, right? Or
So they would use a different process or workflow to create that secondary volume. And then whenever they bring up something in this stateful set, it would pre-provision the volumes from that data set.
Provision, that means you create a volume, it's an empty volume. When you create a new volume, right? You have to take the second step to be
I'm just saying that it doesn't need to be, like if you're creating a stateful set and you want to provision it, when you're provisioning new volumes for the stateful set from a source, it doesn't need to be from a snapshot. It could be from...
So the benefit of being a snapshot is it keeps us in the control path, keeps us out of the data path. As soon as we decide that we're going to allow an arbitrary volume to be the source, then you end up in the data path.
So for current stateful set workflow, so they have this volume claim template. Yeah, right now.
Oh, okay,
yes.
I see. So you're referring to so not all storage provides this, where you can create a volume from a snapshot. So you're assuming that the storage platform supports create volume from a snapshot. Okay.
Right.
So you're not actually copying data. Okay.
Okay. So I'm not sure how much time. So basically, it's just before we are trying to like solve the problem that after you take a snapshot, you may want to share snapshot across different namespaces because snapshot object is namespaced. So this is just a potential way because now we have two objects. Then in order to share across different namespaces, admin need to create the data object by copying some information. And then user can create a volume state object, but specify the data name in the spec. So the controller just checked state and binds those two objects together. So you'll be able to use the snapshot in a different namespace. And so the current status
Sorry, on that last slide. Some platforms may hold snapshots as just all volumes. And so in this case, you'd basically be saying if you're going to share a snapshot, you're actually sharing a volume. Does that make sense? Like
so,
it's sort of a storage platform thing, but we might think about how this interacts with all the different platforms out there.
Yes. Like GCE, snapshot is global, kind of global thing. And for AWS, it is a region thing. So we might need to take a few steps, be able to, but here the sharing namespaces for Kubernetes namespace is not the cloud platform like sharing.
Yep.
So yeah. And currently, we have a kind of external snapshot repo, and you can check it out, and you can try the examples. And it is used out of tree, like custom resource definition API, and has external provisioner. And GCE AWS OpenStack is what we have as the cloud provider, and anyone interested to contribute and can add their providers in the repo. And we are considering to move to in-tray as alpha in release 1.9, but it needs to go through like some testing and also approval from API team. And yes.
I wasn't abreast of the recent design changes, but what caused this to become from an in-tray project to an external storage project? The first design talks that Jing has talks about like snapshot request object, and it gives the impression that it's supposed
to be in tray. Yes, so because at that time we are not exactly sure how this looks like, and we want to make more like prototype to concept of proof, to be able to more easy for us to control. Yeah.
You're going to see this, I think, more as a pattern in Kubernetes overall. Brian actually has been talking about feature releases a lot more, where you do a lot more of work initially out of tree before in tree. I know you've also been talking about, trying to keep things stable. You've noticed what we've all noticed.
So the experimental
A little bit, yeah. In some cases, when it's easy to do so, why not do it? I think was the goal.
Okay, thank you, everyone, and I do appreciate any feedback, comments, and contribution. Thank you.
All right, so let's take a 5-minute break, and then we'll resume at, let's do exactly 3:30, and we'll do one more hour with Brad Childs on release engineering.